Hello guys, we are on 5.5. 5.5 they say determine the general solution of x in the following equation. Okay, we are given the equation like that for 5 marks. Okay, let's give it a try. Okay, we are having the equation like that. Okay, we are having it like that. Then let's try it. Okay, when we try it like this, okay, we are going to use the law of exponent there, okay, which is going to enable us to distribute this. Okay, we're going to do it like this. We're going to have 3 tan of x there, okay, again multiplying the 3 tan x there. Okay, remember when we are having the same bases which are multiplying each other, you add the exponent. Okay, and when you add the exponent, you just write one base, then you add the exponent. Okay, the bases are the same, then you write one base, then you add the exponent. Tan x plus tan x gives us 2 tan x. Okay, so now we are reversing, that's why we are here. Okay, then again we come here, we do the same thing. Okay, that means here we're going to have we're going to have the 3 tan x there. Okay, multiplying 3 to the exponent 1 there. Okay, the bases are the same, then you write one base, then you add the exponent, then it's going to be tan x plus 1 here. That's why it's like that. Okay, then you're going to bring this one to the other side. Okay, when you bring to the other side, it's going to give us negative 54, then you end up with 0 that side. Okay, then here when you check here, we are having the 3 to the exponent and x here and there and there. Okay, but we are not having it there. Okay, it means we cannot take out the common factor. Okay, what happens here, to make life easy, we say we let 3 to the exponent tan x to be equal to k. Okay, you can use any letter there. Okay, it means where there is 3 to the exponent and x, will replace it by k. Okay, then here we're going to have the therefore, then we're going to have k multiplying the k. Okay, here is it, I replaced it by k, and here even k. Then we're going to have k 3 subtracting the 54, should give me 0. Okay, k multiplied by k give me the k squared, then here I'm going to have the 3k minus 54 equals to 0 there. Okay, now I'm having a quadratic equation there. Okay, then I can try to factorize there. Okay, here I'm just having k squared, then here I must have k. Okay, k multiplying k gives me k squared. Okay, now I must look for factors of 54. Those factors that I multiply, they give me 54. When I add them or subtract, they give me negative 3. Okay, if you can't factorize, you must consider the quadratic formula. Okay, it's the easiest one. Okay, let me try 9 multiplied by 5 gives me the 45. Let me do the 6, give me the 54. Okay, and there I can use I can say 9 and 6. Okay, since the middle one is negative, then the bigger one here should be negative, then here should have the positive. Okay, then here use the 0 flow. I'm going to have k negative 9 be equals to 0, or k plus 6 should be equals to 0, then my k should be equals to 9, or my k should be equals to negative 6 there. Okay, we are having it like that. Remember, the k we said is equal to 3 to the exponent x, 3 to the exponent and x. Okay, sorry, then here we are saying therefore, then we replace k by that. Okay, then we're saying therefore 3 to the exponent tan x should be equals to 9, or 3 to the exponent tan x should be equals to negative 6 there. Okay, then we try to simplify. Okay, Then let's try to simplify it, okay? We start with the first one there. We are having the return to the exponent x, okay? This side we are having the 9, okay? With the 9, I'm trying to with the 9 I'm trying to represent it in the base of the rate there, okay? Then I come here on my calculator here, okay? Then I say equals to, I say 9 equals to, okay? Then I'm saying shift, then I look for fact, then here's fact, okay? Then it gives me the rate to the exponent 2, okay? Then that 9 I replace it by 3 to the exponent 2, okay? Then this side I'm having 3 times to the exponent x be equals to negative 6 there, okay? With this one, okay, if we can try to express the negative 6 there, negative 6 we say equals to, then we say shift fact, okay? So what have I done? Negative 6 shift fact, okay? It gives me the error there, okay? Then here, even if we can try the log there, okay? Remember, if we want to remove something on the exponent, we can use log, okay? Log this side and log that side. You're going to be able to remove the tan x there, okay? But here, remember, the log should be here and there, okay? And let's try the log of negative 6, okay? Then it gives me the error, okay? Then with this one, it means the rate to the exponent and x can be equal to negative 6, okay? Then we cross it like that. Then we remain with this one, okay? Remember, here we are having the same basis and the equating. Then it means we should take the exponent, and then we're going to have the tan x being equal to 2, okay? Remember, we are looking for the general solution, okay? With the general solution, you start with the reference angle, okay? Start with the reference angle, okay? With the reference angle, it's like we are solving for the x there, okay? Then this one we are saying literally should go to the other side, but when it goes to the other side, it becomes the arc. Then you're going to have tan arc of 2 there. Then that should be our reference angle, okay? Then the arc of tan 2, it gives us a 63.43 degrees there, okay? Then here, since our tangent is positive, we're going to look for the quadrants where tangent is positive, okay? Tangent is positive in the first quadrant and the third quadrant, okay? Then we start with the first quadrant. Okay? In the first quadrant, then we take whatever it is here. Since here we're having x, we are just write it like x like that, okay? In the first quadrant, we are just having the acute angles, okay? Our reference angle are always acute, then we just take it like that, okay? Rho as it is, then we're going to have 63.43 degrees there, okay? Plus, then here we must take care of other solution in other quadrants, okay? Then we are going to add the k there, okay? Multiplying the period of tangent there, which is 180 degrees, okay? Where k is element of integers, okay? Remember, this is the solution, okay? It's the solution in the first cycle, okay? But we can have other correct solution in other cycles. That's where we are having this. That's why we are saying we are generalizing. We are having a general solution. This solution is generally, it affects even other cycles, okay, in whatever direction. Then we said we must consider again the third quadrant there, okay? In the third quadrant, again we take whatever's here to the left hand side. We are having the x equals to, then in the third quadrant we are having 180 degrees plus the reference angle there, okay? Then again we must take care of other solution in other circles where k should be element of integers, okay? Then here we do the algebra. I can come here to say plus 180. then I get the two 43.43 degrees plus k multiplied 360 degrees. Okay, then we are done. That's the general solution. That's the general solution. Okay, that's the general solution. That's 5 marks. That's our 5 marks. Okay, we're having it like that. Okay, let's recap. We started somewhere here. Okay, where we expanded it like that for it to be more visible. Okay, then we said let this equals to k, then we substituted, then we had the quadratic equation there, then we factorized, then we said k equals to that or that, then we replaced back k by that. Okay, even there. Okay, then we went on our side, then we expressed the line in that fashion. Then here we said we can execute this. Okay, because even using the log we're going to struggle there. Okay, then that's why we crossed to say this can be that. Okay, so then we dealt with this one only. Then here we took it like that using the laws of exponents. Then the reference angle like that, we are having it like that. Tan is positive in the first quadrant and the third quadrant. That is the solution in the first quadrant, and then the solution, another solution in the third quadrant. Okay, then we are done. Okay, bye.